If you loved mystery novels as a child, and you may still love them, what was your favorite part? Solving the mystery, right? That's not a surprise. But how fun was it putting all the clues together and the story finally making sense? It's the joy of suspense. Well, in this lesson, we have a quick mystery for you to solve, but you may still find it fun. Let's start building up our clues. Remember how we wrote complex numbers as ordered pairs? These points made a new set called set C, set of complex number. In this larger set, there is a subset that contains special pairs. How do we identify it, you may ask? Their y-coordinate is 0. And why is this special? You'll find out soon. Addition, subtraction and multiplication work the same way for this subset. And they are a little easier. Good news, right? Suppose you have 2 points that belong to it. Can you predict their sum? It's so simple because the y-coordinates are just 0. How about multiplying them with a constant k? Once again, super easy because 0 multiplied by anything will still be 0. So we won't even bother checking it. The same applies next. We notice getting the product of complex numbers is always the longest process. Not here. All you need is one little step for this subset. And there we go. Finally, the multiplicative inverse if a comma 0 is considered. Its inverse is just the reciprocal of a with comma 0. Just remember that in order to keep the fraction defined, a cannot equal 0. Otherwise, the point wouldn't belong to our subset. Are you getting closer to solving the mystery? Yes, the results are the same as we should have obtained while operating with real numbers only, because the imaginary component has played no part in any calculation we just saw. We represent this finding mathematically like this. It's an important result, so I am holding it as 1. Now, what if we set the real part as 0 instead? Like this pair, 0, 1. Square it and apply the product formula. Then, a little simplification will bring you this, which is nothing but just -1 according to our previous finding. Now, if the square of 0, 1 is -1, then the same ordered pair without square would be square root of -1 or iota, right? This is the second important finding. Let's label it as 2. With these two, we are in position to write every complex number given as an ordered pair in terms of I. How? Pick this. Using the addition law, the x and y coordinates can be written as a, 0 and 0, b. Then, isolate a and b from the right side of the equation. It's possible, thanks to the multiplication law of ordered pairs we saw last time. And it's finally the time to put these two in action. This real part becomes 1 while this imaginary component is replaced with I. So, we just end up with this notation of the complex number. This is great news for us. We can convert complex numbers from one form to the other without any problem. I must say, you guys are getting so good at complex numbers that by now they must start to seem like simple numbers. Am I right? Great job, team. Now see you in our next lesson.